Welcome to The Explainer. Today, we are tackling, well, the biggest topic of all, the end of our world. We've all seen it in movies, right? But believe me, the scientific story is way more incredible. So how's it all going to end? That question seems pretty straightforward, but the science tells a much more complex and honestly, a much more fascinating story. See, there isn't just one answer. There's a whole spectrum of possibilities, and they stretch from the geologically near future all the way to the deepest, darkest reaches of cosmic time. Okay, let's dive in. We're going to go on a journey through time. We'll start with the dangers that could happen on a timescale we can almost wrap our heads around, and then we're going to zoom all the way out to the ultimate fate of the universe itself. You can think of it as a kind of cosmic calendar of catastrophes. All right, let's start close to home, in our own unpredictable neighborhood. We're talking about the threats that play out over thousands, maybe millions of years. Now that sounds like a long time, but on a planetary scale, these are the dangers that are not just possible, but pretty probable. What's really interesting here is the symmetry of the threat. You know, Earth faces danger from both the outside in and the inside out. A giant asteroid slamming into us, that's just a random cosmic lottery. But a supervolcano? Well, that's a geological time bomb ticking right under our feet. And here's the crazy part. Despite their totally different origins, they could both trigger the exact same terrifying outcome, a planet-choking winter that could pretty much end civilization. And oh, the list of potential problems doesn't stop there. Some are these slow-burn planetary changes, like a runaway greenhouse effect that turns our world into a place we just can't live, or the gradual collapse of our planet's magnetic shield. But others, and this is the scary part, are entirely of our own making. I'm talking about the ever-present risk of nuclear war, or some technological disaster we can't even foresee yet. Okay, this timeline really puts things into perspective. See that tiny, tiny sliver on the left? Yeah, that's all of human civilization. The next supervolcano seems like a long way off, sure. But now look at the incredible jump in scale to the death of our sun, and then that mind-boggling leap to the end of the universe itself. We're literally shifting from planetary risks to cosmic inevitabilities. So even if we manage to dodge every single asteroid and somehow avoid every self-inflicted disaster, the Earth itself has a finite lifespan. It's not our permanent home. It has its own internal clock, driven by the immense heat in its core, and that engine is not going to run forever. So how does a planet die from the inside out? Well, it gets cold. You see, Earth's liquid outer core is like a giant spinning generator, and it creates this protective magnetic field all around us. It's an invisible shield, and it deflects the most dangerous radiation from the sun. But over billions of years, that core is slowly cooling down and hardening. And as it does, that generator sputters, the magnetic field gets weaker, and our atmosphere becomes vulnerable. Eventually, it could get stripped away by solar winds, leaving the surface exposed and sterile, kind of like what we think happened to Mars. It's like the planet's battery is just slowly running down. And from here on out, we move beyond risk into pure certainty. This next one isn't a question of if, it's only a question of when, because this destiny is written for our solar system by the very laws of physics. You know, there's a really profound irony here. The very star that gives us light and warmth and all life will, in its old age, become the instrument of our planet's destruction. The sun is about halfway through its life right now, and its final act is going to be spectacular, and for Earth, totally terminal. So here's how it happens. It's this dramatic chain reaction. Once the sun burns through all the hydrogen fuel in its core, the balance between gravity pulling in and fusion pushing out is just broken. Gravity wins. It crushes the core, causing the temperature to skyrocket. This superheats the hydrogen around it, forcing the sun's outer layers to swell up into a monstrous red giant. It's going to get so big that it will literally swallow the inner planets one by one until its fiery edge reaches us. Earth will be completely vaporized. The good news? We've got about 5 billion years. Now for us, that's an unimaginably long time, but on the cosmic calendar, it's the final chapter for our planet. And there is absolutely no escaping this particular deadline. But what happens after the Earth is gone? After our sun dies? What's the ultimate fate of, well, everything? The story doesn't end with our solar system. So let's zoom out one last time, to the scale of the entire cosmos.
So when we ask how the entire universe will end, we are right at the very edge of physics. We have several mind-bending theories, but they mostly fall into three camps: the long, slow fade, known as heat death, the violent tearing apart of the Big Rip, or the instantaneous reality rewrite of vacuum decay.
Heat death is the leading theory. It's not a violent end at all. It's a slow fade to black. It's driven by a fundamental law of physics called entropy, this inescapable tendency for everything to get more disordered. Think of it like a hot cup of coffee in a cold room. The heat always spreads out, right? Over trillions and trillions of years, all the energy in the cosmos will do the same, until the temperature is the same everywhere. With no energy moving around to power anything, stars will die, black holes will evaporate, and eventually, absolutely nothing will happen. Just ultimate eternal stillness. And then you've got this far more dramatic idea: vacuum decay. The theory here is that our universe might not be in its most stable state. So if a tiny bubble of a more stable, true vacuum were to just appear somewhere, anywhere, it would expand at the speed of light, instantly wiping out our reality and replacing it with one with totally new laws of physics. We would never, ever see it coming. So, after that journey from asteroid impacts all the way to the death of reality itself, how do these endings stack up? Let's put them all side by side and see. When you look at them all together, you see this really fundamental shift. The near-term endings, like an asteroid impact or a supervolcano, they're a matter of probability, of chance. It's a question of when, not if. But the long-term endings, our sun's expansion and the universe's eventual heat death, they aren't chance at all. They are certainties, written into the very fabric of physics. You know, exploring the end of the world isn't really about being morbid. It's about perspective. This whole journey through destruction, from planetary risks to cosmic certainties, it gives us this profound appreciation for our fragile, beautiful, and fleeting moment in the cosmos. It's a reminder that our time here, right now, is an absolutely extraordinary gift.